it's all right. I don't know what I've done.
Right, we're going live. No swearing and whatever. I want to introduce Dave and John, who are going to talk to us about something very interesting to do with trees and QGIS. So I'm intrigued.
Thank you, Dave. Good morning, everyone, or afternoon as it is now. So I'm Dave Partridge. I'm GIS consultant. Work for myself as Neat Maps, and I've worked with tree economics for the past 5 years. I'd like to introduce John Rose, who's an urban forest consultant. And we've not met until today, although we've worked together sort of every week for like the past 12 months or so, haven't we, John?
Yeah.
So so we'll take you through our presentation. I think we've got a bit of a tag team going on. So John will go after me, and then I'll do a bit of QGIS, hopefully with a live demo. We'll see how that goes. Maybe it'll work, maybe it won't. And then you're going to wrap up at the end, aren't you, John? So
that's the plan.
That is the plan. Thanks, guys, for all the tech, getting that working. So we'll see how we get on.
All right.
So let's go for it.
Yeah, don't touch it.
Sorry. We haven't rehearsed this.
Right. Hello. So urban forest consultant. You probably go, yeah, I understand what those words mean individually, but what do you actually do? That should become reasonably transparent as I go forward. That's a tree. Okay. So work with trees. This was from a project last year. Still got 2 key workers in the foreground, so you can still get the feel for it. This is a tree from the Green Park, which alongside St James Park is the 2 parks right next to Buckingham Palace in the middle of London. That's a London plane tree, and you kind of typically collect high-level information on it. So we know how high it is, its diameter. DBH is diameter at breast height, which is basically tree hugging height. So it's 1 3/4 meters across. It's 5.5 meters around. And we think estimated weighs about 16 tons. It's got a canopy of about 500 square meters. And if you took all the leaves and spread them out, you've got a surface area of about 4,000 square meters. It's a phenomenal piece of bioengineering, and it captures water from rainfall. And we talk about it preventing stormwater runoff to the level of about 7 cubic meters a year. So when you see all those stories about the drain's been overloaded when we've got stormwater, all the trees are helping reduce that amount. So if you don't have any trees, you've got a bigger problem. It also captures pollution. So it absorbs when it's sulfur dioxide or nitrous oxides, or particularly good at particulates. So the small little bits and stuff we get down at 2.5 microns that come off the brake pads and the tires and in the diesel exhausts. And it sequesters carbon. So this tree will do something like 60 kilograms a year that it will pull in out the atmosphere when it's going through its photosynthesis and capturing the carbon dioxide and releasing oxygen. It's a massive oversimplification of what photosynthesis is, by the way. In total, that tree, it's half carbon in simplistic terms. So 8 tons of carbon is stored in that tree, including all its branches, its leaves, and its roots. And that's valued at about just over £6,500. So that's the value at which we will take the government's sort of social cost of carbon and apply that to the tree. And it's got various other metrics for the annual benefits for the tree in terms of that £169 there. We also have 2 other figures. So to replace that tree normally would cost £140,000. I don't think it could. You can't really replace that tree, but the calculation on that's done based on smaller trees and scaled up, and it's given an amenity value in excess of £750,000 for 1 tree. And those figures, that figure at the bottom there, is driven by access for we as public have. So urban forestry is about trees, the forestry bit, and people, the urban bit. So it's very much about those 2 things. And where geography plays a huge role, if we were to shut the park, not let people into the park, that figure at the bottom would be £300,000 instantly, because it's about people having access to it. If that tree was here in Bovey Tracy, that figure at the bottom would suddenly be down at about £100,000, because there aren't very many people that live around here. So it's the people make a big difference. to the numbers there. If we were to move the tree up to Manchester, that water level would probably double or treble, and the value associated with it. If we put this tree, moved it out of the park and moved it into Barnet, which we're going to talk about in a little bit near some of the main roads there, the pollution figures would jump up, and the value of the pollution figures would jump up. So where that tree is makes a huge difference to how we think of it and benefits we get from it. Now, urban forestry is not just about a tree and calculating the various bits and pieces we get benefit from it. It's about all the trees. So how do you look after all the trees in one go, and how do you understand them? And a client for us would typically be anybody who's got an awful lot of trees, which would tend to be local government or government entities. So this is London. So that is a map showing all the public trees in London. Now, you'll be familiar with the idea that data is never quite as full and complete as you want it to be. So there are some holes in that data. So I'll see if I can identify them. Can you see that? Dot, a little dot. So that's Brent Council there, didn't supply their data. Down here, that's Richmond Park, and that's Wimbledon Common. That's Hyde Park, and just here, that's Buckingham Palace and Green Park and St James Park, and that's where the tree that we've just been looking at is based. Taking both the GLA and the local councils, everybody kind of wants to plant a lot of trees these days, whether it's national government initiatives or it's local government initiatives or it's local councillors. Everyone wants to put trees down. And where we get the most benefit, we've said, is where all the people are. But where the people tend to live is where there's a lot of concrete and tarmac and pavement, and it's quite difficult to stick a tree in the ground. And as you all appreciate, money tends to be quite tight for everybody. So the problem for local authority is, where should a limited tree planting budget be focused to deliver the most benefit to residents from increased street tree canopy cover, i.e., where do we plant our trees? Which streets, which exact locations, how many trees? So to boil that down another level, so well, actually, I've got some very specific parameters to deal with. If I'm going to dig a hole in the ground, a tree pit, to spec, it's got to be 0.5 metre by 1 metre. But I've also got to have pavements wide enough, even after I've dug that, to let other people pass. Prams, wheelchairs, us as pedestrians. I can't have my trees too close together, or I don't get the benefit of them. They start overlapping. I need to maximise that benefit, so I'll keep them 5 metres apart. And then I've got the fact that I've got some 750 miles of roadway in Barnet. To do this job manually, it's going to take a very long time. So my question to Dave was basically, how wide are the pavements?
Thanks, John.
So I'm now going to hand over to Dave.
Thank you, John. So yeah, John came to us and said, how wide are the pavements in Barnet? And I originally thought it was going to be fairly easy, and I wasn't correct. I knew we were going to use OS Mastermap as our base data set because it's up to date, lots of attribution. That was going to form the basis of the answer. So those of you that know Mastermap, feature code 10183 gave us a real good sort of starter for 10, really. So it shows there on the picture all the yellow pavements. I use the word pavements and roadsides interchangeably, so it's the same thing, the bit you walk on. So that looked good. I thought, oh, this is going to be straightforward. We're almost there. Then I started to think about, okay, well, how actually am I going to classify these pavements into the sections that John needs? So I started Googling it. Was there a formula that I could use? That's one. That's the thinness ratio. If you've ever looked for sliver polygons before, I thought, oh, there's bound to be something out there on this. I'll be able to use it and just say to John, there you go, it's all done. But there wasn't. Was there a plugin that I could look at in QGIS? I found this Xtools plugin or add-on for Arc, which I wasn't using, which bisected each polygon and dropped a point down halfway along, with an attribute being the width at that point, which wasn't quite what I was after. And obviously I was using QGIS anyway. Then I went on to good old Stack Exchange and started getting my mind a bit blown. So there was this. And there was a few criticisms around it saying it was only approximate and didn't give you exactly what you wanted. Don't know why that happened. And then there was some stuff going off into real weird maths using fractals. So yeah, so I was desperate to sort of answer John's question, and I wasn't quite sure which way we were going to go with it. So I then kind of thought about the problem in a different way, or I took a step back and tried to keep calm about it, and that we didn't actually need to know. I didn't need an all singing, all dancing thing saying the pavements are exactly this wide at exactly this place. We just needed to be able to break it down and classify it into sort of broad thresholds as dictated by the client. So where they were narrower than 2 meters, where they were between 2 and 3 meters, and where they were greater than 3 meters. And that would do us really. So I was thinking, well, that might be quite easy to do or lend itself to using buffers. So I did a bit of testing on that theory. The only thing we would do would we be buffering each pavement negatively. And I'll show you the next slide will illustrate that. So there's a little extract of the road network or pavement network. If we're checking to see if those pavements are, say, in this case, 2 meters or wider, if we buffer them all by -1 meters, so half the distance, if anything gets created, then that will be the test case. That will prove our case. So anything that gets left must be narrower than bigger than 2 meters, and anything that doesn't get created will be narrower. So here, where we got the pink stuff, there's still a feature there, so that pavement must be greater than 2 meters. Where nothing gets created, that must be narrower than 2 meters. Okay, so that seemed to work. One issue we had was that roadside widths vary an awful lot. So how do we go about classifying? There's just 2 examples there. What would you call those? I mean, you got a few little remnants left from buffers here on the right. Were they 2 meters wide or less? Where am I actually going to classify this? How am I going to answer that question for John? Not quite sure yet about how to tackle that, because they vary so much within the data set. Also got a large volume of data. So this local authority in Barnet, has a quick calculation, that's the whole view, over 15,000 features, 10 million vertices, and if you sort of spread out all the roadsides, they'll cover 500 hectares. And I've done this a couple of times, correct me if I'm wrong, but I've worked it out that that'll span over 1,500 miles of the pavements, which will take you from Land's End to John O'Groats and all the way back again to Exeter. So that's a hell of a lot of data to just look at and try and classify. So QGIS has got a little tool on it called Subdivide, which is really great. So it's in the toolbox already. And it was useful to me for 3 reasons. It'll break features down into smaller, more manageable segments, and you can choose how broken down it is by changing the value in the dialog there. We could buffer the results of each segment, and then I could use those to extract and create little clippers, which I'll show you a bit later on in the next couple of slides, to sort of chunk out and clip out the data that I'm interested in. It also meant that the laptop I had, it didn't need to be that powerful. The older one I was using just used to hang when you gave it a problem. But if you use Subdivide, it tended to sort of chunter through and work through it quite happily. And also Subdivide, just the last little thing, Subdivide was available again, all there in QGIS from the processing toolbox. So if we look at subdividing and buffering on this example here, so that's Subdivide. So it's just split it into smaller chunks, smaller, more manageable chunks. We then buffer those. Again, we're buffering them negatively, so the things are getting created inside the pavements. Where there are no features, it's got to be 2 meters or less. Where there are features, it's got to be wider than 2 meters. So that was all seeming quite good. Seems to work. So then I talk about these clippers. What's all that about? Well, what I'm doing then is I'm then rebuffering these pink bits. So where I get something left in the middle, I then buffer it by my original search distance. So I buffer those pink bits by 2 meters, and that creates these clippers. So I decided I gave the clipper a round end cap and I dissolved the result. So if I use this pointery thing. So here we had 2 very small buffers, internal buffers, one here and one here. But my overall external buffer was dissolved. So it's just 1 buffer. Okay. So I dissolved the result. And if we go on through and take that through, I then use those clippers and I clip the original data set. So I end up with a nice clean looking data set of pavements. And I've got all the attributes that are still there from master map as well. So that includes all like the natural, the surface that it's built on top. Is it natural? Is it man-made? That kind of thing. So all good so far. So that's basically it in essence. So I then just put it into a model in QGIS again, using the model builder, which just took some of the pain out of the process. So I'm not sure if you can read that, but these are like little zoom ins of the bits in red. So I'm adding my pavement layer. I'm running the subdivide, and I set the tolerance there to 50. I found 50 worked quite well, had quite manageable, largish chunks of pavement. I then subdivided it, and then I did a multi-part to single part just to explode all those little features. The next bit is I'm actually then buffering those by half the distance. So again, say if we're looking for a 3 meter wide pavement, we buffer it by minus 1.5, so negative half of where we're looking to see if anything is left. And that would take care of that for me. And I had a little variable just called pavement width, which then would, so I could just type in 3 and it would do minus 1.5 for me. So I didn't have to think. Then I would remember those pink bits, that's then externally buffered to create my clipper. And then that clipper clips the original pavement data set. And that's it. So I'll now try and do a QGIS demo. So I'll break out of this and just show you it in action, if that's okay. Fingers crossed. So here, you can't see it. Why not? Okay, so I'll just kill it, shall I, Dave? If I end show. Thank you. Brill. Okay, the screen ratio is a bit weird, but it'll show us pretty much what we need to. So here I've got my wards data. So I've only got 1 ward of pavement data, which I've already extracted for us. I've just chucked a little background map on there. And if we go into the toolbox, I'll just very quickly edit my model. So in here, I'll say 50 nodes. So I'm chopping the pavements up using 50 nodes. And I'm going to look for pavements that are, let's say, 2 meters wide. So that's where I type it in. So if I run that model, I just need to point it to the roads data set, do a run. So that's finished. If we look at our output, I'll just step you through. So I'll zoom in somewhere. So here's our pavements, original data set. They then get subdivided. So hopefully you see some black lines. They in turn then get buffered. So I'll try and find somewhere where it's a bit narrower than that. So they in turn get buffered. That's quite a good area. Got a mixture there. Those buffers, so those red bits get in turn, they get externally buffered. So they create my clippers. And then I can clip out the data and I end up with my result, if you like, which is my pavements of minimum width for that particular category, which is the blue stuff. So that's my 2 meter data set. I could then repeat that for 3 as well, and then so on and so forth. So the demo actually works. So I'll go back into PowerPoint and run the current slide. Yeah. So If we run it a couple of times, we've got our at least 3 meters wide and our at least 2 meters wide data. So we're almost there. So we're now able to classify our roadsides finally, but there's one last thing I need to do. I need to do a difference between the 2 and the 3 because pavements that are at least 3 meters wide are also at least 2 meters wide. So there's an element of double counting there. So I need to cater for that. So I need to do a difference between the two. Again, difference is in QGIS. So we just do a difference and then we get our between 2 and 3 meter data set. So there we go. So that's our kind of final classified map. And we've got our areas there. So we've got our 2 to 3, which is the difference. We've got our at least 3, which I think is what I did on screen. And then we've got where nothing gets created, it's got to be under 2. There's one little bit of refining that we had to do to the output. And that was where we had adjacent strips of OS master map that were narrow. They didn't know that they had a neighbour right next to them that could also be used. So together, in reality, it was a wide-ish pavement, but it came out of the model as being a very narrow strip. So these two here, you see in yellow, one's on the inside, one's on the outside. Because again, the surface has changed. One's man-made and one's natural. That's that actual street. And you can see there's kind of 2 paving slabs by people's driveways and then more of a sort of softer strip going down. So that was captured as natural. And the one to the left was man-made. But for our intents and purposes, all of that is on the cards. So we kind of we searched for where 2 narrow strips were next to each other and reclassified that into a wider pavement. And then we removed the existing canopy because we're not going to plant trees where there already is trees. So we used 2 data sets. So we've got the dark green data that we removed, which was Blue Sky's data set, the national tree mapping. And the local council also done their own tree survey. So they put a point with a spread. So we put that in as well, where they'd done their own. So we removed that from our kind of equation, if you like, our search area. And then it was a case of saying, okay, how many trees can we plant based on a 5 meter tree spacing? So we just bunged a hexagon grid on top. And any centroid that overlapped a pavement was a candidate area for planting. As a kind of aside, we also cross-referenced it with something else that we do, which is a hotspot map. So we look at things like pollution, deprivation, air quality, and we say if you planted a tree here, flooding is another one, if you planted a tree here, it would be of massive benefit. So we kind of have a hotspot map across the district, which we cross-referenced with our results. So if you take that all to its conclusion, we ended up with sort of tree planting sort of candidate areas, and they also had a kind of score about how good they would be, how they would benefit the local authority. I think that was my bit pretty much done. So I'll hand back to John for the wrap up.
Great, thank you. So that gets captured a nice report, and I end up with maps that look like that from Dave, which is great because he's had to solve quite a lot of problems to get to the point. I just want to know how many trees can I plant in each street. That's kind of the question that we've got, and you can see it's quite a complex point to get to. Where am I going? Right. So I then wanted to dive in and have a look. So I've picked one little bit to dive into, and there you go. So that's a bit of a. So if they don't quite match up, that's because that's my lack of ability to match them up. But you've got a Google Earth view down, or Google Streets view on there, and the map at the bottom. You can see that the can't get the point. Can I get the point?
Yeah, you're right.
Pointer working?
Yeah.
Oh, there we go. Yeah, so you can see there's a distinct lack of trees along there, and we're saying that's a good place to plant all these trees. You'll see that some of the places the centroid doesn't land, and it's the grid doesn't quite match, but we're looking at the number of trees. So I'm not going, we're going to plant an exact tree where that job spot is. There's also, it's picked out the grass, big chunk of grass at the end. So that's great. It's doing the job that we need it to do. And that means that the local authority, the tree officer in the local authority can really go through, do a desktop study using Google Streets. And that's his first search based on the maps where we think the tree should be. then he's going to spend his expensive resource going out and doing the final check. So the final check is, this is on that little green corner where we went to plant trees, and then you immediately come up against all the other problems. So we could look for pavements and soft landscapes, and where we've already got tree cover, but what we didn't have access to was BT phone cabinets and lamp posts and underground services. So understanding where those are is the next problem, and you can't plant a tree there. So, because that's an immediate issue, but that's a decision for somebody on the ground to take. We can definitely plant trees along that road, just not quite on this corner. And if we manage to do that, one day we'll end up with something that looks like this, transforming the thing, arguably lifting those property prices by 10 to 15%, because that's how much we will pay to live in a tree-lined street. And that concludes us. So, thank you very much.
Thank you.
Any questions? Probably for Dave, but
John.
Were the situations where people went out on the ground and looking at that slide at the end of the map, looked like there were some areas that were maybe at the end of people's drives? Was there that kind of situation that was encountered? What about? Yeah, that one.
yeah. So the curb drops.
Yes. Is it possible to classify it?
That's a good question. Dave? So at the moment, we didn't take that into account. That's another one of those aspects where we need, so this is our first run through this. So second run through, my first call was street furniture. But actually, you're absolutely right. Curb drops and access to the driveway for people parking is another one. And it depends to what extent that data is captured by the local authority. So if it exists, yes, we can use it. If it doesn't exist, it's a manual job. And typically it may not exist in a format that we've got, but we might be able to access it because somebody's had to apply for planning permission to get permission to drop the curb. So we probably could get an address run and then run that through.
I should have prefaced that by saying it's an amazing bit of work, really impressive.
I've just checked in OpenStreetMap to see if there is a dropped curb.
Oh, yeah.
Yeah.
And I can't find it. I was
Right.
wondering again with your BT infrastructure whether if you looked in OpenStreetMap, conflated that with the OS data.
It is possible. We were looking at speed limits as well, weren't we? And some places it's captured and others it isn't. But I think there's probably better data sets than OpenStreetMap for that from the local authority. But we didn't end up using that in the end, did we? For this particular one.
And one of the challenges is even the planning data doesn't correspond to what's on the ground, because this is what we think we want to do. Whoever turns up to install that stuff is going to deal with the reality on the ground, and they may go, can't do it there, I've got to get it done today, I'm going to move 10 metres that way. And
what about Sam's machine learning algorithm on satellite data, finding your drop curves and your
it may well be that there's a solution in there somewhere. Yeah. But the client's was very pleased with the results of this, and he kind of the first thing was, so you're telling me, John, I can plant what 20 trees along there? Cynicism coming through his voice. Right, let's have a look. And he just opened up Street View and he found a street. And he went, yeah, well, I guess we should have planted those years ago. There's a big 5 metre wide pavement that with devoid of trees. So he's very pleased, because for him it saves a lot of money, because he can do much more of the job from the office now before sending out that very expensive resource to do the groundwork.
And it's worth saying that the 2 metres and the 2 to 3 metres were really just something that Barnet and talking to you, John, have come up with, because there isn't a nationally agreed.
No.
So like we're looking in another local authority, and they've got slightly different criteria for their accessibility, like how wide they need pavements to be.
Yeah, they want to be 2.2 metres wide.
So we can do that. It's easy now. We just plug it in.
But I'm putting curb drops on the list. So we'll put that in for their program. It's Brighton I'm working in next, so that'll go on the list. And they've added a new one in actually, which was they've on the coast. They have very high southwesterly winds coming through, which means that you can't plant trees won't survive when it's fully exposed. So the topography and the buildings make a big difference where you can plant trees. So that's another dimension that will be relevant there that wasn't relevant in Barnet.
I do have a question related to that, kind of the next stage. Where's the decision making around what type of trees to plant? Because you'd have like overhanging canopies over private property, for example, or like roots that were damaged, potentially pavement.
So in the public domain, which is all this, so all the land is owned by the council, and they own all the trees that get planted in that space. If it rips up, they are therefore liable to any damage to property and people. So that's what, if you've got a tree on your garden, it falls over and damages the neighbour, that's your problem and you're liable. So the council's liable in this situation. They will make decisions over species choice. Typically they're inheriting a lot from previously, and in very large parts of the country, those are trees planted 150 years ago in some cases, and they've just ripped up the pavements. And you've got decision, do we chop the tree down, given all the benefits we get from it, or do we just find a way to live with it? So some places they'll do the former, and some places they'll do the latter. If a tree's overhanging your property, I'm afraid that's kind of just tough if it's the local authority. You can't, if it's blocking your light, you won't get any redress from that. So having your property, you won't get redress from that. If it's your neighbour's tree, you've got a bit more clout within that. It's only when it starts to touch your house will they come along and fix the problem. And you might go, well, that's really kind of quite unfair and quite challenging. But if we were really strict on that, so you can't have anything overhanging any other barrier, we wouldn't have any trees out there. So every time we prune a tree, we basically damage it, we wound it. And if we have to do it in a very careful way so the tree manages to survive and we extend their lifetime in what's quite a harsh environment. But a very good question, because that generates all sorts of issues.
Because as much as people like to look at trees and raise their property value, they don't like it when canopies are overhanging the property.
No, so what people, the perfect scenario is a street full of trees except for outside your front door. So if we could all have that, that would be great. Yes. Yeah.
Is climate change being taken into account? Because I live in a block of flats, and we have a couple of trees in the middle, and they were really suffering this summer with the lack of water.
So the straight answer is massively. Everybody concerned is a huge part of what they're trying to think about. But when the trees are suffering, when we suffer, the trees are suffering, and the sort of 2 weeks that we've got it, and you've got to water all the trees. So in terms of a resource demand spike, it's massive. You can't solve the problem from a council resources. You can't employ enough people to do it. The real answer to that is that we will take on part of the challenge, or we design systems so that the current generation of tech will enable us to build you come across sustainable drainage systems. So you can build them into the roadways, the side of the road, they'll capture the water. The best version of those will capture water, store it, and allow it to be fed back to the tree in times when it's drought. So that will cope with a lot of the gaps. The bigger, older trees will survive the gap. Small, young ones are toast. Basically, a young tree who's been planted in that March won't get through the summer in that situation because it's got no reserves. Whereas a tree like the one I put up there can probably afford to lose all its leaves 3 or 4 times over before it's got real problems. And the last bit on the climate change is people are now looking very much to change the species they plant. For example, one rule of thumb would be take the trees that are currently living 10 degrees south of the point at which you are, because that's in simplistic terms, the climate you're going to be living with, or we're going to be living with in X decades' time. So it's very much active part of the agenda, yes. Sorry.
Yeah, so thanks for the presentation. Great work. I was curious about the future applications for this work. I know you just touched on it in terms of accessibility for pavements, but is there an idea to maybe look at, cycle lanes on roads, like good candidates of roads, potential bus lanes, like what roads are good for it? You can see some really exciting avenues in this work.
Yeah, lots, but we haven't gone anywhere near that stuff. I think where we were focusing on is how do we get better at refining this so there are less, when you get on the ground, it's a more accurate result that represents the issues on the ground. And actually, from a tree planting perspective, cycle lanes and bus lanes occupy real estate that you cannot stick a tree into. So we've only got so much space to deal with. So we have to take them into account. But they're, from a tree planting perspective, they're a problem. In wider society, they're a solution, but it's, yeah, we'll just have to deal with it. Okay, I can see food at the back, by the way.
Yes, thank you very much, guys.
Thank you.